This is the fundamental theorem of calculus part 1. So it's basically derivatives with definite integrals. So we're going to do a little warm-up of actually doing what we're supposed to be doing and then find the quick way of doing it, which is our fundamental theorem of calculus part 1. So we have an integral here, and what we're going to do is find out what it is. So the integral of sine of t is cosine of t with a negative, and then we put in pi and 0. Should seem familiar because we did it before. So this is cosine of pi minus cosine of 0, which would be negative 1 minus 1. And so that gives us 2. So now if we bring down our derivative of this thing that we're trying to be doing, because when we work our way out like this, what is the derivative of 2? It's 0. So the derivative of our definite integral from a constant to a constant is 0. Well, what if we replace that with an x up there? Well, let's try it again. So this would become 1/3 t cubed x to 0. So this would be 1/3 x cubed minus 1/3 times 0. And then we would now take the derivative. Now I'm leaving the other one as 0 because I just want to make a point. This is a constant. So if we take the derivative of a constant, that second term, regardless of whatever it is, a 2, a 3, a 4, it's still going to be 0 when we take the derivative, just like what happened here. So we're going to always end up with 0 here and subtracting it, but not this one. So this one now has an x in it. So when we take the derivative with respect to x, the 3 comes down and cancels, and we end up with x squared. So our answer is x squared. So hopefully you can now see our formula. If we take the derivative of this definite integral, that x is just getting placed in. Because if you remember, this right here is our derivative. And we take the integral, it gives us our antiderivative. But the derivative is just taking us right back. So that's our derivative. And by taking the integral, we're getting the antiderivative. But we slapped a derivative on the outside, so what's it do? Well, it just takes us back to here. All this is doing is replacing that t with an x. It's converting it into an x, and then we're taking the derivative with respect to x, taking us here. So we end up with this. This is our fundamental theorem of calculus part 1. So our function f is continuous on our AB. That's our restrictions from before. Then the function g is defined by this. So is continuous on IB and differentiable on AB. Then g prime of x is equal to f of x. So all we're saying is if you take the derivative of g of x, which is our integral, all you're going to do is plug in x. So it's super quick. All we really did here is put the x in front of the t, in place of the t, and we get x squared. So if we want to find the derivative of this, what do we get? 1 plus x squared, and we're done. It doesn't even matter what that constant is, remember? Because it's just going to be a number here, and when you take the derivative of the number, you get 0. So I could put a 2 here, a 3 here, a 4 here. It doesn't really even have to be 0. It's still going to be this. That's it. So all we're doing is putting a square root, 1 plus, and then replacing our variable with an x. So again, why is this true? Well, let's look at it. We know this is our g, which is giving us this, right? And if you remember, f prime of x is f of x. So now if I take the derivative here with respect to x, I'm now taking the derivative of our integral. And so on the other side, it just becomes f prime of x, because that is an x, right? Minus, and this is a constant, right? So that becomes 0. And so what do I end up with? F prime of x. But what is f prime of x? Well, f prime of x, this is our antiderivative. That was our derivative. So it just becomes f of x. So you got a t here. The x goes in. Now it becomes f of x. That's all you have to do then is just plug the x in for t, as long as it's 0 to x. Now on with the chain rule. So this is a little different now. It's not just an x, it's a square root of x. So it works the same way, but we have to apply chain rule. So when I plug in the square root of x, I would get square root of x, parentheses squared, over 4th power plus 1, square root of x, times, and we've got to do the derivative of what we plugged in. You see how it's in a parenthesis? So that would be our chain rule. So what is the derivative with respect to x of the square root of x? And that becomes the derivative with respect to x of x to the half, right? So we already know that becomes 1 over the square root of x. Oops, with a 2 in front. So we end up with 1 over 2 square root of x. And then now we can just simplify a little bit and see what we get. So that would become x over x squared plus 1 times 1 over 2 radical x. And then the radical x and the x will cancel, giving us radical x over 2 x squared plus 1. And again, we have to see why. So again, here is our h of x, which is this. So we would end up with this, our antiderivatives. So I'm not going to write the ddx this time. This would just become f prime of radical x. But look, do you see how that radical x is in a parenthesis? So then you're going to have to go, okay, times ddx radical x. And again, this is a constant. Let me put that in blue. That's our constant. So again, that would be 0. So you end up with f prime radical x times d dx radical x. So if you're taking the derivative with respect to just plain old x, you plug it in. If you're taking the derivative with respect to x and you have a radical x up here, well, then you plug it in just like before, but you do have to take the derivative of whatever you plugged in, just like this.